All right, so we're on part 4. In part 4, I did not put I had to decide. I'm trying to keep it down to 4 pages. I did not put the Desmond steps, but these were the steps for Desmond. So back to what I was saying. The main thing that you need to remember from Desmos is what's highlighted. You'll see the highlighted up there. The Y1 squiggle line MX1 plus B. That is the main thing that is not on your notes, but if you don't remember it, I would write it at the top or the bottom of my part 4 notes so I can remember that when I'm in Desmos. The key thing is how I type in the algorithm or the pattern, which is the Y1 tilde MX1 plus B and the Y2 tilde MX1 plus B. Okay, so those are the main things for Desmos. We're going to model again both, but I had to decide which ones to put in your little foldable thing and which ones not to, and I chose not to put this one in your foldable. Does that make sense? Okay. Otherwise it would be 4 pages and I couldn't do this. So yeah, cool. Okay, we're gonna follow the ones in your notes first. So we're gonna follow the handheld calculator. There should be calculators on your desk. If there are not, just send one person to collect calculators for your table if you do not have enough. All right, so we're going to practice using our handheld to find our solution here. Here it said that you have the population of New York City and Los Angeles from 1950 through 2000. Okay, it wants us to assume that these linear trends continue. When will the population of these regions be equal? So when, meaning what year, right? And then what will the populations be? Okay, we're going to go through the steps of finding this. The first thing we're going to do is we're going to round our values on our table. Okay, our calculators are smart, but the smaller numbers that we allow it to work with to find a regression model, the better and faster it works. Does that make sense? So remember how we talked about forcing a zero? So we're going to force our zero at 1950. If 1950 is 0, what does that make 1960? And it keeps going, right? Cool. We're going to take our populations and round them to the nearest million-ish. So instead of writing 12, I'm going to write 12.9. Instead of 14, I'm writing 14.8. Instead of 16, 16.2. Does that make sense? Yeah. So these are the values that we're going to be putting in our calculator. Cool? We're following the notes. We're using our handheld. Okay. So I'm going to open Sylvie. And I'm going to open and reset Sylvie. So here she is. To reset, I'm going to go second plus 712. Oh, guys, I put the completely wrong notes on here. Oh my gosh. I just realized that. I copied and pasted the Inspire steps, not the 84 steps. Those are all wrong. Yeah. It's all right. We've done it before. You already have these notes in your notebook. So you already have regression notes in your notebook, by the way. I was trying to put them back on there. But in the haste in me in my middle of the night working, I copied and pasted Inspire, which I really don't even know how I got there. Who knows? I haven't used Inspire in a while. So somehow I copied and pasted the steps for Inspire, but that's okay because we already know how to do this. So we're going to go to Stat. Do we remember doing that? We're going to go to Edit. And we're going to Input. So the first thing we did was we went Stat. Then we went to Edit. And now we're inputting. Easy enough. So now I'm going to put in my 0. How did I get here? There we go. So I have 0, 10, 20, 30, 40, 50. Now I'm going to put in 12.9 million, 14.8 million, 16.2 million, 16.1 million, 18.1 million, and 21.2 million. Remember, the best way to learn is to do it. If you don't do it, then it doesn't become part of a normal thing for you. I'm going to put in 4.4 million, 6.7 million, 7.0 million, 11.5 million, 14.5, and then 16.4.
Wait, what to put for the second row?
Excuse me?
What did you put for the second row? For population?
What's on your paper? What's on your paper? It says 21.19. I rounded it to a 21.2. It's on our paper. Guys, look at your notes. All I'm doing, you have the paper. You don't need me to type in data. The data is in front of you. Okay? Are we all done with step one, or are we still working on step one? Okay, seems that majority of us are done with step one. Okay, so we're gonna do step two. Step two, we're going to make sure all of our boxes are filled in. Are they all filled in? Yes. Now we're gonna press stat. This time we're gonna go to calc. And we're looking for a linear regression, so 4. So I'm gonna go stat, calc, and you see 4 for linear regression. So stat, calc 4, yes? All right, step 3 is the added part. We want this to store it for us in the calculator. Okay, so we're gonna go down to store. Do you see where it says store? Store REQ, regular regression equation, REG, I'm sorry. So we're gonna arrow down to store. Now this is where it gets a little weird. So I'm gonna write it out and then I'm gonna do it. Is that cool? So from store, we're going to go to vars. From vars, we're gonna go to function. And then from function, we're gonna either choose Y1 or Y2. Because we gotta repeat. Are you ready? So I went down to store. I'm gonna press vars. Go over to Y vars so I can get to function. Oh, probably should add that in there. Add in Y var. There you go. So I can get to function. I'm gonna press function, and this is my first equation. Does that make sense? So this is my Y1, so it's my first equation. And I'm gonna press enter. And now I'm going to calculate. I surely will. Okay. Here we go. Doing it again. So we were at stat edit. All my boxes were filled in, correct? Okay, you want to be over there? Cool, Sylvie. I'm going to press stat, calc. I went to linear regression. Everything else is good. X list, Y list. And I'm going to go to store. From store, I press vars, Y vars, function. And I want it to be graphed as Y1. So I press 1. And then we calculate. I don't know if I need to write calculate as a step, but I will too.
We'll put those two. Write down what they give us for A.
Yeah. So we're gonna write Y1 equals 0.147x plus 12.886. Now we're gonna do the same thing for y2. That's why it says you're gonna do y1 or y2. So step 4 is repeat. So I'm gonna do it again. Stat, calc 4. This time, instead of using L1, L2, remember this was L2 and this was L3. So I need to change this to L3. In order to change it to L3, you're pressing second plus 3. So second and 3 is going to change it to L3. So now we're going to go to store. Vars. Again, why do they have it hidden? I have no clue. I personally was hoping that they would have put a shortcut by now to get to the y values, but they haven't. And this used to be my y2. And I hit calculate. And we get approximately 251 thousandths times x plus 3,804. I don't think I got that last time. Let me go look at my table.
I have the same thing somehow. You run into fatal part.
Am I good? Okay. For some reason, I got 4. Yes, I will. Just checking my numbers. Okay, cool. Do which part again? Stat, calc, 4. I list this time as L3. So I went second, 3, because initially it falls, it's automatically set to L2. But I'm on the second list that I wrote, right? My third list. So I switched it to L3. You went to store, vars, y vars, 1, 1, oh, not 1, 2. 2. And now I hit enter. And I have 3 and it's 5. 805. Yes. All right. What this is telling the calculator to do is to automatically graph this without rounding to the very end. So when you go to your y equals, notice that the calculator has all of it typed in. As it's rounded as far as it could into the calculator. Does that make sense? Now, could we write all that out? No. Would we want to write all that out? Okay. So this gives us a better accurate answer. Does that make sense? By storing it and making the calculator hold on to that. Now, when I go to graph, Sylvie's thinking. That's what that little circle means, that she's thinking. When I go to graph, I only can see one graph. So because I only can see one graph, I need to do what? Change my window. I do not need negatives. Time goes on. I'm just going to see what 100 does. I do not like a lot of tilly marks. I do not need negatives. Again, I'm just going to go up to 100. I do not like the little lines all across. So when I hit graph, now I see one line, then I see the other line.
What do you do again?
I change my window settings to make it where it's something I can see. I don't like zooming in and out because the zooming in and out gets weird sometimes. Okay. Okay, so we repeat. Now we graphed. And so after you graph, you want to find your intersection. Does anyone remember how we said we find our intersection last week? What do we press? What? Second, trace. Second. Then we press trace. And then we press what? 5. And then we do what? What's the sum to 3 times? Enter. Enter 3 times. Okay. So we're going to go second, trace, 5, and then 1, 2, 3, and it gives us our intersection. So it says it intersects at 86.8. Is it 8? Comma 25.6. What does that mean? In terms of this problem, what does 86.8 and 25.6 mean? So 86 is our years, but 86 is the years from where? So from 1950, 86 years, 86.8 years later, the population will be the same. So how do I find out what that year is? Just add them, right? What is 1950 plus 86? There you go. So in the fall of 2036, the predicted population will be roughly 25.6 million people. Does that make sense? That is regressions with systems. We spent 3 weeks on regressions. Just put that out to y'all. Instead of just doing 1 now, we're doing 2. But that's the gist of it. Okay. Now, if all else fails and you prefer to do it in Desmos at home, as long as you have the y1 tilde mx1 plus b, can you do it at home? Yes, Desmos, you're typing in the same info, correct? Add your table, type in your values, and then you just gotta remember. Okay, on Thursday, we'll have a quiz over 4.1. So make sure you're comfortable with these notes and that your notes are completed. No, it wasn't me. It was Khan Academy.